Thank you very much for the kind introduction, and I'd like to welcome you all after the lunch. We already discussed it's a little bit, okay, we are all a bit full and settled. So I have to wake up you a little bit and give you some energy, and hopefully I'll do this with my talk. And we are going to talk a little bit about data-driven development, foundation models, AI in general, because I have the privilege to be of a research institute, so I'm not business-driven in the first way. So I can talk a little bit more free and give you a little bit of an overview of my view or our view on what is happening right now. And yeah, that's what it's going to be. And first of all, I want to take you to a little journey. Like 10 years ago, we had a project with a customer. This was a big prototype Mercedes-Benz future bus. And we were asked to do the perception and planning for this. And they took a basic vehicle of themselves and they want to do a show. 2 days, Amsterdam Schiphol Airport, bus rapid transit line to city, 20 kilometers roundabout from the city to the airport, bus rapid transit line, so you have separate lanes, only buses are operating there, so a little easier environment. And we started like 1 year before the event with the development, and we collected the first data. It was all camera based and GPS at that time. Collected the first data in winter. We collected data, trained our models, started the first test drives. Everything looked very good, perfect, promising. Even the tunnel was no problem, easy. So we tuned our models a little bit, did some parameter tuning so that it feels good, especially for the bus stops where you have to navigate very closely to some centimeters. Everything was working, and the event was in June. And like 1 or 2 months before the event, we went onto the site again, wanted to test everything once again and optimize it a little bit, and nothing worked. Absolutely nothing. And we thought like, okay, what is happening right here? We couldn't really figure it out. And of course, in winter we had snow, dark lights, low sun. In spring, everything was green, a lot of flowers, colors overall, and we had to completely collect new data 2 days before the event, retrain all of our models. And yeah, it's just to show you the importance of data. And this is still one of the key success factors to bring automated driving to life, even 10 years ago and right now. And this is what we're going to talk a little bit about the next 50 minutes, and also what has changed since then with respect to the AI models, which is also very, very interesting. Just to give you a brief overview about FZI, so my name is Stefan Otten. I'm a division manager and I'm leading innovative teams since over 10 years ago. Innovative teams in automotive development and AI, and especially in automated driving. And as an FZI, where I'm responsible for a division. We are a non-profit research institute located in Karlsruhe, Germany. We also have a branch office in Berlin, and we are working very closely with German OEMs, tier ones, especially southern German OEMs, of course. And we also have quite a little history in automated driving itself. So we had our first prototype vehicle in 2011, a cognitive car, was it called at that time, because it had the first cognition of the environment and surrounding. We did the Bertha-Benz memorial route. Maybe some of you know, they had a great show of this memorial route from Pforzheim to Mannheim with Mercedes, where the first Mercedes car drove as an autonomous vehicle in 2013. This was non-AI based, only rules and static planning. Then we did the future bus and also some other projects. We had shuttles operating in real environment. But we also investigated into different fields, like combinations which were merging right now also with robotics, with logistics, with transportation mobility. So everything is now a little bit combining. And since 2 years, we have our next generation car. And we always do not only think about the Sandsplan Act, so the chain itself. We always thought about this complete development, engineering, testing, analytics data from scratch. So this is also a focus of what we are doing. And if you see now a little bit from a broader view what is happening the last years, with respect to AI. I mean, like we came from classical machine learning. Like 15 years ago, we did some feature, for example, predictive maintenance, some specific feature development for your pump, which is breaking somehow. You had very specific sensors there. You did some handcrafted features. You trained this, and you had more or less separated models per task. And then the first thing which came up was all these deep neural networks, where also the first video I showed you based on. So we had the possibility now to learn from raw data, and there was like one example which was also the time like 2015, 16, where this whole autonomous driving was a really real hype. I remember like 2017 I was on CES and every booth had autonomous driving on it. Was really funny, even companies who don't have anything to do with automotive, but it was the big hype. And the idea was like you take some input sensors like cameras or whatever, and you just have an end-to-end network, deep network, which steers and decelerates the vehicle. So this was the first capabilities of deep learning, and in AI it's always like you can have great results really fast and showcase things really fast, but at the end it's all about getting these edge cases like we discussed in the morning before, and this is all about data and training. And now we see the next shift with foundational models, which more or less based on transformer architectures, and transformer architectures are not a new concept. This paper is like from 2017, Attention is All You Need, where this idea was introduced to bring in capabilities that you don't train models for one specific task. For example, I mean, with deep learning, for example, you have the perception models where you can do really good perception, bounding boxes, labeling, whatever, but you cannot use this model for anything else. And this was the idea to have like some kind of transfer to other areas, and of course you need capabilities with respect to compute power to have this in a massive multitasking and parallel way. And this is what we see right now, and where a lot of things are happening at the moment. I mean, we in research can't even cope with the speed. Things are changing. I mean, if you look at the GPT versions in 3 years, it's really fast. And we also see these kinds of models, of course, in automated driving. And all different kinds of types. I'm just subsuming them all under foundation models right now, but you have the classical LLMs, the VLMs, the multimodal LLMs, where you try to use different modalities like images, like LiDAR, like whatever, different modalities, text, video, in combination, to bring more or less more capabilities and more knowledge into these kind of models. And they are very data-centric, so it's all about the data which you put in. And I just pick out some examples. We had the talk in the morning, the NEO model. Everyone is bringing in models right here now at the moment. So you have a lot of movement here around. Everyone is trying to place itself in this kind of fields, because we believe the capacity or the capabilities of these models are very high, and there is a good chance that you can really benefit from these models for the tasks you want to do them. But if you take a closer look, you don't have any fundamentally new algorithms since 7 or 8 years. All progress which was made the last years, all what you see in these GPT things, all progress we see is driven by data, the right data, by better training methods to do this in a more efficient way, by combining things, and by compute power, of course. But no new algorithms. It's all the same idea, the same basic concepts. And this is one thing which is really interesting. And the other thing, foundation models are very good in one thing. They are very good in semantics. They have a very good understanding of how human beings think. They are trained more or less with internet scale knowledge. So they know if there's a ball on the street right here on this image, maybe children can come afterwards, and that's why they are very good for reasoning, for thinking, for interacting. But they don't have any idea about any physical component. I mean, like if there is a plastic bag on the street or a ball or whatever, they don't have any feeling about material or any idea about the material or about physical constraints. You have this example, like you have a scissor. Can a scissor cut a car? The LLM or VLM doesn't know. It doesn't have any idea of this. So you need to bring in additional capabilities. And in automotive, these are, or in, let's say, it's not only automotive, but in every real-world environment domain, these are especially temporal, geometrical, and physical abilities. And this is what a lot of things, or a lot of things are happening right now to bring this kind of combination of VLM, LLM, multimodal language models, to bring these together with these kind of capabilities. And this is also what you call physical AI or world models or whatever. There are so many buzzwords at the moment. But the main idea is to bring in these capabilities together to advance there. And this brings me to the most important point. Everything we see is like based on data. You need to have this kind of iterative approach, and you need to have an idea about what data you need, you want, and how to bring this into your development lifecycle. This is why we focus a lot on these data-driven approaches. And there we see, like 10 years ago, we always had this big data. You just want to collect millions of kilometers. It was all like you need to argue that you have driven 10 millions of kilometers or whatever. And we did a lot of dashboarding there, like KPIs and metrics for your countries and stuff like this. It was all about big data in big cloud centers. And there we see some movement. We are going on to smart data since several years right now already, because you do not need all the 20 million kilometers on the highway where you just have one car in front of you. It doesn't matter at all for your function. You need the right data. So you're investigating into bringing in more knowledge, like picking out the right scenarios or abstracting the data in a very appropriate way to generate knowledge, and then decide which data is really relevant or new for your function, also with respect to edge cases, which we discussed before. And the next step, in our opinion, is to have like fast data. So to do this decision in the vehicle, not in the cloud at the end, where you have like all your data stored and you do this decision in the backend. No, you wanna do this in the vehicle, like in an iterative approach, very fast, to just pick out the data you need for your specific functionality or your data set you want to achieve. And therefore, of course, you need some kind of edge capabilities to have some triggers, monitoring conditions, whatever, and you need to have an awareness about which kind of data you want to see, which kind of events is occurring, to what kind of frequency. And I just want to give you a little overview about one project we're doing at the moment, where we see this kind of approach of the collection and analysis as an iterative feedback controlled loop. So we give some feedback in the collection, in the vehicle, and then decide on the fly which frames we take for our training and which frames we just drop, to reduce, of course, costs with respect to transfer and bandwidth, and be more efficient. And one example we have here, like we have some kind of distribution we want to achieve. We approximate it like it's a Gaussian distribution, and of course, in our strategy for the selection, we want to select the kinds which are not represented well enough in the data set already, which we want to select more of them and select less of those who are really overrepresented right here. It's a basic idea. And to give you an example, like taking some camera front camera images like here, and really basic example, we have like the number of vehicles in the frame as the KPI right now, and with a closed loop feedback strategy, of course, we cut off like these kind of data sets which are overrepresented and try to balance these on the fly in the vehicle. And this This, of course, we do in more complex scenarios, but just to give you an idea about this kind of topics. To be more efficient at the end, to collect less data without losing information. That's the basic idea, and to do this in the vehicle very fast. And this is what we call fast data, where we are heading in our opinion. And if you take a look again at the overview, of course, you have different data sources here. The real-world data is one of the basic fundamental sources, but of course, we have this testing AD next to us. We had this in the talks in the morning. You could simulate also your data, or you could generate, or AI synthesized, we call it, your data. With respect to simulation, I don't want to go into detail because I'm not a simulation expert. There are other people in. But with respect to synthesization by AI, of course, it's very interesting again to look at the new models, generative models, foundation models. What can they support in data generation with respect to input data? And the first things we came up with, like 5, 6 years ago, was the idea of augmentation. It was the generative adversarial networks, GANs. At that time, and the idea is very simple. You take like augmented reality. You take a picture from the real data set and you augment things in a way that it's really realistic. And we did some experiments with that, but this had some limitations. And the last years, of course, like already mentioned, the foundation or generative models came up, and these were more promising with respect to generating data here. And this is where we also investigate, and there are several research projects already also going on right here. And the basic idea is like you prompt more or less the data you want to add to your data set. And this you could do in a very easy way, like a man crossing the street of one camera image with different weather conditions or different types of objects in here. But of course, this can get more and more complex if you don't think about single images, if you think about streams, or if you think about even complex scenarios you want to generate, not only single data points. And these are very interesting things. There's also a lot of movement going around, and things are combining with kind of simulation, closed loop, generation things. I think there is a lot of movement going on. And it's really interesting for us to be there in this spot and in these topics right now. So with this, I want to sum up a little bit and just give you some key takeaways. For me, still data-driven development, data is key success factor for scaling these kind of end-to-end AI approaches. Foundation models need domain-specific adaptation capabilities, like physical, geometrical, temporal aspects. And we see one aspect of this is like shifting from the big data approaches, like big collection, to some ideas like doing this fast and efficient in the vehicle. For this is all I have brought with me. And just one last quote: better use error-prone data than using no data at all. Already a philosopher like 150 years ago already said that, and I think that's still a very true thing. Thank you very much.